Today we're going to be studying the term factorization of trinomials more specifically. So we have this very simple equation, x squared plus 9x plus 20. So we can break this equation in two parts. So over here you have a constant, and over here you have a variable with an exponent. So first you have to see if the variable has basically it's a method where you can simplify a quadratic equation which results as a product of two linear expressions that can determine the values of the variable. So in this case, it determines the values of x, a constant with it, a coefficient. So you multiply that with the constant, and whatever the product is, you find the factors of that, and if the factors add up to the middle variable, then you have your factors. So let's try this here. Since x means 1, we don't have to multiply that with 20. 1 times 20 is 20. So factors of 20, we have 2, 5, and 4, and 20 and 1. So to make 9, we have 5 plus 4. So we can break that up here. 5 and 4. 5 plus 4 is 9. So we can just write 5 plus 4 in brackets. Then outside the brackets we have x standing out, and we still have the 20, and of course x squared over here. So when you open the brackets, you multiply everything with x, and you get x squared plus 5x plus 4x plus 20. So now you have to try to break that in. X squared and 5x, something common in these two. So what I find common is x, because x has 1 next to it, so 1x specifically. But if you just take x out, you are left with 1x plus 5. And then over here you have 4x plus 20. In 4x plus 20, you have 1x, so you have to try to get the same thing over here, so you can find one in common and take one down, if you know what I'm trying to say. So plus 4 and 20. So 4 and 20, 4 is common, so you can take 4 out, so you have x plus 5 left. Now you have x plus 5, because x plus 5 and x plus 5, you can cancel one of those out. X plus 5 and x plus 4, that's what remaining. So that's how you factor trinomials. So now let's try a problem where there's actually a coefficient with x. So over here we have a more complex problem, 6x squared plus 23x plus 7. So over here, x has a coefficient of 6. 6x squared and 7 alone. So 6 times 7 is 42. So we can write that over here at the side. So if you think of 42, the factors are 1, 2, and then you have 42, and then so 23. What two factors of 42 do you add up to make 23? So 42, if you break it up, it's 21 plus 2. So if you write it down in brackets again, and x at the side, 7 and 6x squared. Open the bracket, and you get 6x squared plus 21x plus 2x plus 7. Now, to factor this, you can say 6x squared and 21x, what you have common is 3x. So you can take out 3x, and you're left with 2x plus 7. And over here you have 2x plus 7. So basically you can just write that in brackets too. 2x plus 7 and 2x plus 7. One of them gets cancelled out. So at the end you have 2x plus 7 in brackets and 3x plus 1, because there's nothing there. 3x plus 1. So that is more complex factorization with the coefficient, with the 6. And those are the basics of factorization. Now you use these in graphing So here's an example. 2x plus 7 and 3 in brackets 3x plus 1 equals 0. So 0 can either equal 2x plus 7 or 3x plus 1. So you write these in two different equations. 2x plus 7 equals 0 and 3x plus 1 equals 0. Then you subtract 7 on both sides. You get negative 2x equals negative 7. Divide by 2 on both sides. You get x equals negative 7 by 2. So, and over here you have you subtract 1 on both sides. 3x. Then you divide by 3. X equals negative 1 by 3.